especially when it's just the two of us, feel free to just interrupt. Honestly, I am recording it anyways, but we might as well kind of get started, and then if people come, all the better.
All right.
Just give me 1 second. I'm just trying to. Oh, there we go. There we go. Okay. So really the focus of today is on errors and error handling, which, was discussed in lecture, but we're going to really kind of, as usual, basically go into, oh, we have another person. Wonderful. Go more into some of the details. So some of the details and actually as well as, obviously trying examples as we typically do in tutorials. So the first thing I want to do is just show an example of a typical kind of function. And so what we're going to code an average function. So let me share my screen here, and let's do this. So for starters, let's code just an average function, right? So we're going to take a list of numbers in, and we're going to and so we're going to take our list, which we can call, I guess, entries, as in like all the entries we want to average, and that will be a list of floats. Or it could be integers, it doesn't really matter. And what we want to return is a floating point, a single floating point value. So now let's think about what we would do. Well, look, all we need to do, right, we need to sum the entries and then divide them. So we could, of course, do a for loop, right? We could do total equals 0 and then do for, for item in entries, item, and then we can return sorry, right? Everyone agrees that's a good function?
Yeah.
So it is. We can, of course, simplify a little bit, right? We can just delete this and it's all commented out and instead just do sum, right? Like that's still a good function. So let's test it out. So yeah, sure. Let's try some values. 1, 2, 3. Looks good, right? I think this will work. It will give us 2. We need to print. I keep forgetting this isn't JHub. Yeah, so 2.0, perfect. But what if we do this? What do you think will happen? Come on, take a guess.
Will it return nothing?
Close.
Or an error statement?
What will be the length of entries?
Nothing.
It'll be 0, right?
Yeah, 0.
And what's this right here?
Division. Divided by.
Yeah, what happens when you divide a number by 0?
Oh, it's an error.
Right? So when we do this, we have a division by 0 error. And so this is a great example of a case where we would want to check for errors. And there's 2 ways that we could really do this, right? So the first way, and this is a problem, by the way, because of course the average of this list is actually 0, and so it's supposed to be 0, but it's actually giving us an error. So we could do 2 things. The truth is the best way to deal with errors, and you should always remember this, the best way to deal with errors is to prevent them. So if you can predict certain cases that will lead to errors, like this one, then you can say right? And then you would avoid that issue. But there is another way, and this is where the error handling comes in, using try except statements, and you can literally just do this. And now we could do return 0. Now there are some problems, and you'll notice it's complaining because it says too broad exception clause. Why? Because basically what this is going to do, this is going to take all exceptions. And we don't always want that, because what if I just give like 5, right? This will be weird because 5, right, it should actually be an error now because I want only a list, and because sum 5 will be an error, and len 5 will also be an error, but because of this line right here, it's going to take all errors and return 0, and I don't want that, right? Like that would not be appropriate. That's kind of removing errors. So if we know what error we're trying to prevent, we should actually type it right here. So now if we run the same code, it will actually give me the real error. So we'll only catch this, but if I once again try an empty list, I'll get the expected result. Now, the other thing is if you do want to catch all errors, you shouldn't do except. You should do except exception. This is especially true on things like Jupyter Hub. If you do except, okay, well, let me show you a good example. Okay, this is a script I'm going to run it. It's going to take a really long time. Yeah? What I can do, I can stop it by pressing Control-Z. But what do we notice? That this keyboard interrupt actually is a type of error as well. So watch this. I hope I don't crash my stuff here. I'm weird. Okay, so watch. If I try to press Control-Z, it's doing nothing. I'm pressing Control-C, and if we actually were to scroll up, we would notice, here, I'll stop it. So in this case, I'm able to basically forcefully shut down the console, but you can see that every time when I'm pressing Control-C, it's just doing nothing. So basically, this is catching all of the errors, including these internal Python errors. That's why you should do this except exception. Now, if I do this, it will stop. So it's only going to catch custom exceptions. It will not catch these sorts of exceptions, which are called like it will not catch internal exceptions. No, I really didn't get that one spelled right. Okay, so this is now a safe version, and we can do better. We can say 0 division error. Now we can, of course, we can list these out too. So let's say we also want to make sure that the type is correct, right? So except type error, let's say, right? So for some reason I put a 5 now. I want it to return a null or just print. Oh no. And it will probably return no value. And again, now if I type in 5, it should just say, oh no. Oh, I need that. See? And of course, the value that it's being returned then is none because we have no return here. Does that make sense? So that's really the average functionality that I wanted to show. That's our most basic error checking example. And I think I've gone over some of the key ideas behind what you should do, what you shouldn't do when it comes to checking errors. So let's just write a function here, which is going to basically assert that something is true. And I'm actually going to do it in two ways, as I frequently do. Let's write a function that will return no value, okay? But what we'll do is we'll basically raise an exception, so it will cause an error if and only if it's not between two values. So basically we have n, and we have a, and we have b. And so if n is in between a and b, let's say inclusive, then we will allow it. That was more than I wanted. Okay, whatever. Not going to waste my time. So, we can do this, right? What we can do, we can say if right, then we're good. And so we could actually do nothing, right? We could just, I'll just, and these will be floats. Float. And actually I would do it this way. I prefer it this way, because then we can say, well, actually, let's do it this way. Then we can say print this value is within have you seen these before? This type of syntax before, Graham?
With the F beside it, or with?
Yeah, the F string.
Yeah, that was in the test, I think, for some of the test cases.
Oh,
But
okay.
What exactly does it do?
Okay, so when you put the F before, it signifies what's called an F string. So basically, if you look at this string, you notice how like I have this in here, but there's no formatting. So if I'll just show you in the Python interpreter. I can say, okay, when I do this, it's going to do nothing. But if I do this, and I put an F before it, it's going to interpret the stuff, anything between braces, as a Python expression. And so we'll basically put A and B in there.
Oh, okay.
It's like it's a simple thing, but it's a nice nice thing. I just figured I would add that in there. Okay, so if it does that, then we're good. Otherwise, what we want to do, we want to raise some exception. In this case, we could raise a value error. I think that's the most appropriate, and that will indicate basically that it is not that isn't the case. Now, there is another way we could try, which I happen to be a bit of a fan of, but that's not. Oh, I did this wrong. And let's actually test this function out before I move on. So we can go to between, and let's let's do 110. So this should be true. This should be true. And then let's do between 1. And this is of course not sufficient test cases, but so we have this value is between A and B, and then we have true. Oh, and I forgot to put the F in here. Excellent. What is it not like? Oh, stop. Okay. Yeah. So that's that part. Now, the other way we could do this, and this is just a fun way I just feel like showing it. It's quite similar actually to what we had before, but we can combine the try and like the try with this instead of an if statement. So what we can do is we can say try assert assert that And this actually, I think, is a nice way to demonstrate how exactly these try excepts work, so you can better understand them a little bit. So what's happening here, right? We have this outer try except, and what it's going to do is it's going to try to execute this code right here, and it's going to stop if there's an error. Now, what assert does, right, is it's basically what will happen is if this is true, it will do, if this stuff here is true, then this will do nothing. It will just keep running the code. If it isn't true, it's going to throw an assertion error. Sorry, raise an assertion error. I'm using not Python language. Raises an assertion error. And so this is, you don't see it, but that's what's happening. Now, we don't want an assertion error in this case. We want a value error. And so that's why I have this except assertion error. The important thing to note is that if this isn't true, so watch, if I do between actually, if I just uncopy these two and just add the word assert for them, what we'll probably observe is, or we will observe, is that it still has the correct behavior. So, insofar as this is still showing for this case, right? So what I'm trying to say is, if this isn't true, it will continue on. If it is true, this will not be printed. So what I'm trying to highlight here is that as soon as an error arises within a try block, the code will stop and it will immediately go to the handling of the exceptions or the errors, and it will not be concerned about any previous lines. They will not execute. Does that make sense?
Yes, it does.
Okay, sweet. Okay, so on that note, let's move on to another one. Okay, fun. I mean, this is kind of a bit silly because we just we just did this kind of question for the assignment, but that's okay. We'll do it anyways. So I'm gonna call this base 32, and it's gonna do that. So essentially, we're gonna have 32 possible options, and we're going to use those. So first of all, let's define the character set for a base 32 thing. Right, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D. Let's do lowercase, that's better. And so basically what we can check. Okay, 32. So that's correct. So what we want to do now is we're going to say not a beautiful name, but that's okay. I don't feel like spending more time thinking of it. And the important thing to note, right, is that as as a base 32, we're going to want to have it as a string. So we're going to do string, and we're going to return, in this case, an integer. So let's do this. So what we want to do, right? Well, we want to loop through, but what's important to note is we want to loop through in order of the the lowest magnitude numbers first. And so instead of looping through from the front to the end, as we know, the lowest magnitude digits, like the least significant digits, are always on the right-hand side. So we're going to want to flip the string first of all, which we can actually just do else. Sure, let's just do it here for simplicity. We can reverse the string. And now we're going to want to loop through, right? And of course, we also need something to store the value as a decimal. So we can do that right here. And then we can get started. So for car in n, we don't even need to voice it. Right. So what I'm saying is we're going to know the value as we go on. And what we can do is we can say value plus equals to the index of, so car set dot index car, right? So it's going to find the number. Basically, it's going to find what each letter means. So what I mean by that is, if there's a V, then we want 32, right? Like a V is 32. What we want to do is we want to add to the value 32 times the magnitude of the position. And the way we can do that is we can basically take what we can call multiplier, let's call it that, times multiplier. And then all we're going to do is we're going to do multiplier will be multiplied by itself by 32, because each step is going to be increasing by 32. And so finally, once the for loop is complete, we can just return value. And I think this will work. So the test case that's in the notes is 1337. Yeah, so let's try. Decimal 1337. Oh, that's the wrong way around. Oh, let's do better. Here's the easy way we can test this. Let's write the reverse function. So once again, we're going to have n, but this time it's going to be an integer, and we want to return a string. So we actually need a slightly different character set here. Well, I'm just trying to think in terms of our character set, what we would want. Oh, okay, yeah, we still want to do it this way. Okay, so what we can do is we can have our output string, which we can call and make it s and make it an empty string. So now what we'll do is we want to loop until n is 0, because we want to basically do the reverse of this. So while there's still value, here we did basically while there's length in the string, add value. And here we want to do the opposite. While there's still any value in the string, sorry, in the integer, we can keep reducing the value of the integer and adding the reduced amount to the actual output string. Oh, hello, we have Anna here as well. That's welcome. Okay, so while n is greater than 0, we can say we can basically add to s. So we can do, I would do plus equals, but I'll show you guys why that won't work in a second. Although the truth is it does actually work. We can just deal with it later. So what we're going to want to do is we're going to want to decide what we want to add actually first. Because what we're going to do, we're adding some character here plus itself. Okay, but the question is, oh, and then, sorry, let me add. And then what we can do is we can just basically make n equals to n mod 32, because, sorry, n divided by 30, like floor integer division, because we want to, we know that kind of with each step it's just going to be dividing the value by 32, like as in leaving the remainder when divided by 32, because what we can do is we can take as much as possible off of the string in that moment, and then take the rest off later. And so we can actually, as you probably know, simplify this as well to that, which I quite like the syntax of. And then I'll just add return s. So now let's figure out what is some car. Well, we can do a very similar thing that we did before, right? So first of all, let's do some error checking, or I guess not error checking, but if n is less, well, I guess 1, or it should be 0, yeah, is less than, n is less than length of character set, right, which will be 31, then we can raise a value error because we won't be able to deal with this case. Okay. Otherwise, what are we going to do? Well, we can quite simply basically go and take the value and use its value according to car set. So if it's 0, which we already know it won't be, it'll be 0. But the reason why it's important that I'm kind of bringing this up is because normally what would happen then is we'd have 0 that goes like, sorry, that we'd have 1, and we'd want 1 to be the first character, right? But it would actually be going to 2 because the index 1 will be 2. But this way, since we have something in the first character anyways, 1 will actually correspond to 1, and so on. So now what we can do is we can basically just did someone type in chat? It was weird. Oh, okay. Yeah, sorry about that. Okay, so so given this, right, what we can do now is we can basically do exactly the same thing we did here. Except the only difference is instead of dot index, we can just take like we can use the square brackets and go into here. And then we also don't need the multiplier because that's being done by the position in the string. So let's say that s is now equal to our set and wait, no. Yeah, actually it is. That's good. Because, yeah. Oh, sorry, correct. I don't know why I said that. N mod 32, because what we don't want, right? We don't want like 150 something. What we want is the actual value. And if we wanted to make this more generic, actually, we could actually just do car set, and then this would actually work for other bases as well. And so that's kind of what we wanted from question 4, right? If you can actually just make all of these into len car set, even though you know it's 32, right? Len car set. And like honestly, that at that point just like works for anything. You know what I mean? So like you could just take any character set and it would automatically convert now correctly. But anyways, it's clear if I have 32. And I'll just put a comment after all of these. Right, and that's the option you have. Okay. So let's test it out. The way we can test it out, of course, is we can just say base 32 to decimal, decimal to base 32. Although I'm going to do it the other way because I don't want to think about base 32 numbers. So we'll do decimal to base 32, 1337, and then we would want to. So this is all going to be a base 32. So we want to go base 32 to decimal here. And of course, we're going to need to wrap it in a print statement as well. Okay, let's run that. Exciting. Uh-huh. Okay, let's just try this thing. And it's less than 0, I think it should be, right? Yeah. Is less than 0 or, oh, because when it's ended, when it's equal to, that was the problem. So it actually needs to be if not. Because it should be allowed to be equal to b. And it should also be allowed to be equal to b here. Okay, I'm just going to change it slightly. The truth is I don't think it's needed, but anyways. N is less than 0 or n is greater. That's so weird. Okay, let's okay, there we go. Well, that worked. So that was kind of unnecessary. But you get the idea. I don't actually, I'm not entirely sure why it didn't work, but clearly that's not a necessary line, right? Okay, so we do have 15 minutes left. So I guess here's what I would do. I mean, I'm happy to go over some of the questions from the midterm. And we can even solve them. I mean, I think Sarth did that in his tutorial, so I can probably do that too. And if you guys have specific questions, I'm happy to answer those as well.
I have a question about the bonus. How would you make the code more efficient? Yes.
Sure, I can show the solution for that, and I'll try to explain it.
Okay.
Anna, do you have any questions?
Hey, yeah, can you go over the practice question for assignment 7, like the first?
Sure,
That'd be
sure.
great.
I
Thank
can.
you.
Why don't I do that first, and then I'll go to the bonus after.
Thank you.
Yeah. Okay. Okay. Please. Okay. Which practice question, or is there only one? No, which one?
It doesn't matter, even if you can do the first one, and then I think I can build on the second one.
Okay.
Thank you. Like I did it, and I got my result was false, so I'm not sure where I was wrong.
Sure. So let's take this. Right. And what we want to do is we want to ignore any non-integer, basically ignore any non-integer items. So we can say if type of I, of I in this case, because it's actually the item, is not equal to int. But in this case, we actually want to, I think we're allowed to do a mix of floats, right? So what they're trying to show here is type X is in these things. So here's what we can do. We can say is not in int float, meaning if it's anything other than int or float, we can continue. And continue will just skip the rest of the loop. The better way of doing it is just like this. So now, let's copy over the test cases. And just like I did before, we're going to assert this. So if it's not true, we'll get an error. Okay, shall we run? There you go. So it worked. Because if it didn't work, we would have had an error. And if we want to be even more clear about that, we can just actually print it. But that is how a SOD works, right? Like if if it doesn't do anything, you're good. If it has a big red thing, you have a problem. Does this make sense, Anna? What I've done here?
Yes. Give me sorry, give me 1 second. I'm trying to see if it's sorry, give me 1 second.
No problem. Take your time. Okay. And okay, so let me pull up my answer for the bonus on the midterm, and I'll try to explain it. Or actually, I'll yeah. Well, okay, well, let me ask this, Graham. Did you attempt the midterm or the bonus? Sorry.
I tried to wrap my head around it, but it was pretty late. Like by the time I got to that question, I was pretty tired. So I tried to like figure something out or do something, but my runtime for I think it might have been like 5,000 characters or 5,000 or no 10,000 might have been like 7 seconds, I think.
Okay.
But I just wasn't sure how to do that. I think did it have something to do with like memorization or something like that? It did?
I'll show you. So for the bonus, do you see this like long blob that I mentioned about algorithmic complexity?
In the question or?
Yeah.
Yeah, there was. I remember reading about
this here.
Yes, yeah, I remember reading that.
So, what I was trying to suggest here is this: if you could somehow implement this algorithm to have a complexity of n, as in, so basically, what the idea is, if you can do this in one loop, that's what you want. So just to give you an idea.
In one loop, holy cow.
Yeah, I'll just I'll give you a bit of an idea here. Actually, I'll do better. I'll open up the collab where I developed the question. It's like an old version of the question, but it's the same question. Okay. So, yeah, so for 2 million, it took 580 milliseconds.
Wow.
Because that's right. That's what because here's what you think about, right? And let me try to find my pen. Hold on 1 sec. Where did I put it? Oh, it's right behind my computer. That would be why. So let's think about like, well, I'll just show you, right? Here's the big thing. Actually, I think I even included in the question, right? Here. Oh, I don't know why I did that in incognito, but look, right? This is the thing, right? This is the difference between x squared and x, or even like x 1.5, or even x 1.1 is like, you know what I mean? As soon as it becomes a power, you do this. And so think about this. When you get to 110 to 10 times 7, here you're still doing, or in this case it'd be 2, you're still doing 2 million computations, right?
Right.
When you do this here, you're doing 5. But it's not 1.7. It's almost 2. So, yeah, right? Like, by the time you even get to, like, here, by the time you're even getting to negative, like basically, I guess that's, well, it's the same, it's, I guess it's symmetric, so it doesn't matter. When you get to 1.3, times 10 to the power of 4, right? That's quite small. It's like, 10,000, whatever. 15,000, we're doing this billions of computations. And Python can do billions of computations. It can't do trillions. And that's why when you can implement it in one loop like this, and there is a way, and I'll try to explain it, it scales so well. It doesn't matter how big the input size is. Like, you'd have to get to I could probably do 1 billion and it would be no problem for this, right? Like, if you think about it, it would take 10 seconds or 15 seconds, but who cares, right? Like, that's when we're talking about inputs that big. And so that's why it's kind of relevant, right? Like, some people question the relevance of this question. Well, this is the relevance. I mean, the big thing is it's a thinking thing. If you want, I can show it to you. If you also alternatively, like, if you feel like it, you could try to attempt it yourself, like with when you're not on a time pressure, and up to you. I don't know. Some people do this stuff for fun. I do, but it is quite a interesting question. I'll put it that way. Like, it is a tough one. It is a very tough one. The truth is, it wasn't originally intended as a bonus. It was intended as a mega bonus, but Professor Moore wanted to make it into the bonus.
Oh, really? So there was going to be, so it would have been 2 bonuses?
Yeah, it would have been a slightly easier bonus and then this mega bonus. But but we decided against that, like, kind of at the last minute.
Okay.
But yeah, I mean, it's definitely harder than the bonus will be on the exam, for example, because yeah, like, we don't. I think one thing a lot of people don't get with this course, they're like, you didn't teach us certain things, and it's like, we're not trying to teach you. Like, we can't, or whether you didn't tell us how to do stuff. So, like, they're like, you didn't, this question, we tell you everything you need to do step by step, and then we give you a question like this, or like even like this question or this question, and it's like, I didn't know what to do, and I'm like, well, then you don't know how to program. You know what I mean? Like, it's one thing to translate written instructions into code instructions, which is like, syntax and the Python words,
right?
But it's an entirely different thing to approach a problem and solve a problem. And in most things, you're never going to get a step-by-step instructions like that. So I think 15 seconds actually is not so bad. Some people were doing worse than 15 seconds for this question, but it's actually shorter. So let's do this one.
So that one took me a while to, like, just question 5 took me a while to, like, try to figure out how I should even approach it. Like, before I put any, like, code in, I had to figure out how exactly it was going to work.
That is the idea. I mean, the truth is, when you get into real programming, if you get into real programming, you spend like probably 90% of your time thinking and 10% of your time actually typing. Like seriously, it's a big difference. Anyways, so let's take let's actually do it exactly as specified. So orientation is a string. We want to return an integer. Okay. So what we can do here is actually, and this is, very few people did it this way. I expect that. I didn't think most people would think to do it this way. But when you get practice, you figure out simpler and simpler ways of doing it. And this was, and what I'm writing out is actually verbatim the instructor solution. So, or it might be a few characters off. But what we can do, right? In the base version, we can just simulate these steps. Like, we can just literally go through these steps.
Right.
So when do we know to stop? Well, we know to stop when there's none of these. And this is a string, right? So we can do this.
Oh, I didn't even think of that. Dang. I use like zeros and ones to identify each thing.
Oh. Yeah, that's an interesting way. There are, like, there's a lot of ways to approach this problem. This is probably the simplest way. Then, what can we do? Well, we can say this. Okay, let me ask you this. What happens if they're, like, on each step, what happens? We take all of these, and we flip them into these, right?
Right.
This always becomes this. So what we can do this.
Oh, shoot.
Now all we need to do is add a counter.
What?
Done.
Holy cow. That it's like a third of the length, or maybe like half of the length of what mine, probably more like a third of the length of what mine look like.
Yeah, I'm not surprised. I think I mean, it's a pretty common thing in general. You people, like, when you're new, you write more complicated things. Like, it's funny because that's actually kind of how you can tell a programming experience. Like, people will look at code, be like, you must not be a very good programmer. Your code is so simple, and it's like, actually that's the opposite. When you have a lot of practice, you don't solve, like, it's not like your solutions look easy peasy. It just people don't come up with them unless they have practice thinking about them using exactly these tools. And so this will work. And if I copy it, well, actually, I don't need to copy it because it's right here. So here we go, right? Same thing. When I originally wrote the problem, I was using RL instead of the arrows. I just thought the arrows were clearer, so I changed it. But it's the same thing, right? So I take this, and then this is, by the way, how I generate the army. So anyways, so even with the default one, for 10,000, it's funny. People were having so much trouble meeting the 10 seconds, and I actually thought it was generous. And so the reason 10 seconds was in there in the first place is like just because Jupyter Hub actually limits it to 10 or 15 seconds, or I don't know the exact number, so I gave 10 seconds so that people don't go, well, like, if you're a little longer than that, I don't think it will be a problem. But anyways, so when you run it, it takes 11 ms to do 10,000.
Wow.
It's still pretty fast.
Yeah.
But if we do the same thing, right, and we compare with the single pass version, here's where we get a huge difference.
Right.
Right? So doesn't look so big, right? 10 versus 3, or well, actually it was 280.
Right.
Hold on a second. What's happening? Oh, this is why. Well, so it's pretty big, right? 283 versus 3. That's a substantial difference, or versus 4 here. But here's where it does make a difference. The instant I add a 0. Because this is running, and look at this arrow. The second it moves to this one, it's going to be done. Still going, right? See what I mean? This is what I mean by how it scales, right? When you have something like that, this is in my opinion the cool part of computer science. Like, it's not just the programming part; it's like how these algorithms actually work and are there. Notice you didn't even notice it go green here. Why? Because it went for 31 milliseconds versus 27.5. So you can see that when you get to that number that's a little bigger, the amount of time that's different is just huge. And so whereas I can do 2 million in half of a second, this would probably take hours or days. It would work. It would still work if you left your computer there. Python would do it. Actually, there are lots of like biocomputation tasks and things that take 2-3 days, whatever. But it would be slower.
Okay. Yeah.
And I know I think you did you have another like a follow-up question for me or anything?
Yeah, I think I'm just gonna have to go over it because I keep getting false, so I'm not sure.
Why don't you show me your code? You can just screen share because it's just a practice question. Like, who cares?
Okay, 1 second.
spoiler alert to anyone.
Can you see my screen?
I can see your screen, and I can see my face.
So this is what I did first. Like, you can see my mouse, right?
Yeah, I see it.
So this is what I did first. It didn't work. Then I did what you did, and it's still not working. I tried about 68 times.
You don't have a loop. You don't have a loop.
Oh, the while loop?
You need a for loop or a while loop. It doesn't matter, but because you want to go through all the elements, right? So after P, on the next line, yeah, you'd want to have a loop there. Sure, while was, I guess.
Oh, you think for would be better?
I think a for loop is easier, yeah, in this case. Right, and then you can just say for like number in the list, or in L. Without the would, without the.
Oh, without that, right?
Without the would, the.
Sorry. Sorry, without the what? Sorry, I can't hear you.
For N in L. And then you need the colon. Yeah. And you also have to, you have to indent. And wait.
Oh.
So yeah, you're gonna, so,
No.
and one more thing, instead of type P, right, you want to do type of the current number. So you want to have type N.
Sorry?
You'd want to have type N there because you don't want to checking the product. You want to be checking that value. No, that's, no, what you had on that line was correct. I mean on line 5. Well, you have type P, you should do type N.
Oh, yeah, that makes sense. Can't multiply by non-int of type list.
So scroll up. Because you're doing times L. You don't want to do times L. You want to do times N. Because you only want to do times the current value. So now try.
Okay.
There you go.
Okay, so can you just explain where the N came from? Sorry, just if you can.
It's just right. So that's how for loops work, right? So when we loop through, we're looping through every element of the list. And so what the for loop lets us do is basically assign a variable with name N to the current value in the list. So basically we'll set N to the first value, it will run the code in the loop. Then it will set N to the next value. Or again do that. And so if we want to think about the whole list, then we can use L. But if we just want to think about, the current variable, which would be 3 or 5 or 10 or, some string that we want to exclude, we can use N just for the current variable.
Oh, okay. Okay.
And so then we have the if statement. We're just checking the current variable and deciding whether or not to include that element in the multiplication.
Oh, that makes sense. Okay, so I was clearly off by my.
Yeah, I mean, you will get a light idea especially in terms of the type checking. Like that was pretty much right.
Okay. Thank you so much.
No problem. And Graham, yeah, so about the bonus, if you want, I can show it to you. If not, feel free to try. I'd be very impressed if you solve it.
Yeah, so would I. And for those kind of questions, it's just like, even to try and figure out how to solve them on our own, it's just like practice, right? Just faster, like, I guess more experience or something like that, right?
For the most part, yeah. I think it's tough, right? So it definitely, like, there's a certain point where it just clicks. I think for me, I had been programming for a while in doing different types of problem. Like, this is a particular type of problem, and doing like web development sort of stuff before I got into like this sort of programming, which actually involves like solving problems. And it was a teacher in high school actually who pushed me to figure out these sorts of things. I think, and he's actually the guy who I got the idea for this problem from. But anyways, I think a big part of it is practice. Another part is just honestly is like just sitting there and being persistent with it. So for example, basically what happens, right? So let's say I'm going to take my code from here, and let's try out some things. So let's try a few things. So basically, like, here's kind of how and this will be useful if you want to actually try and solve the bonus,
Okay.
because it'll what?
Pardon me?
And if you want to try and figure out the bonus on your own time, this is going to be useful.
Okay.
Oops, it should be this way. So and then you'll understand why when I said take a highlight, like when I wrote in the question take a highlighter to it, I was actually being serious. Like that was a hint. The highlighter specifically. So here's what I mean. Yoo-hoo. Why you no run?
Oh, sorry, I can't. Oh, could you share your screen?
Oh yeah. Sorry, I don't know why I wasn't doing that. That's silly. Okay, just give me 1 sec. Yeah, okay. Thank you for saying that, Graham. Okay. So I don't know why it isn't printing the result here, actually. It's like it's just not running the code. Funky? Oh, that's why. There we go. Okay, so that did what we wanted, right? It probably printed on the previous line or something, yeah. But that's the idea, right? It's giving us 0 for this, but then for this, we're getting 15. Okay. Now, okay. So what I'm basically doing here, let's try out a whole bunch of values, and then we're going to copy them over. So for some reason it's not actually, and let's just try out the values in the actual test case. Try out this one. And let's also, this is a bit of a long one, but we can try it out anyways. I'll try out this one too. I should remove the spaces. We can do this one as well, which isn't too long, but okay. So now let's copy this into OneNote. Make the font very ginormous and get highlighting. So what we can do, we're looking for some patterns. So, I mean, the first thing we'll note is that there's no lefts here, right? There's only rights. Here, let me turn off my camera while I'm pointing at my face. Is that we have no lefts. Okay, and so we know that there are none. Now we'll also notice that certain things are not true. The length of the string then doesn't have anything to do with it necessarily, because we have a string of length 6 and it's 0, but then slightly longer is 7. Okay, now what we also determine, and in this case what I'm basically looking for is, are there patterns in the string that I could find out on the first attempt, where I could go through it, find these patterns programmatically, and then basically go straight to this number without simulating every step. And so I'm really just looking for, how can I solve this problem in the cheapest way possible without doing the steps, without actually even knowing the final orientation, but just knowing the result. But in this case, we actually will know the final orientation, and I'll tell you why. What we'll also notice is that every output, right, every ending is going to be of this form, right, where you're going to have at some point in the middle, somewhere in the middle, it's going to be asymmetric possibly, but at some point in the middle we're going to have this piece here, and then we're going to have on the right hand side of that only rights, and on the left hand side of that only lefts, right? Now we can also notice something else, and I'm going to take oh, was this in the midterm? That's fun. Technically it wasn't supposed to be, not that it matters. So if I take a screenshot of this, let me throw it in here. What we'll also notice, right, is we can track the position of these lefts and rights, right? So at this point, we have 0 in the correct orientation, okay? Well, and when I say correct, I mean they're in the final orientation, right? Because we don't have anything here, and I'm just looking at these two, because I know that these two need to be like this. After that, like if they're not, then really nothing else matters, because like, yeah, this one is in the is technically facing the right direction, but it's not in the correct orientation because it's going to switch right away. So now we have 2 in the correct orientation, and they won't move. Will never move again, right? Now we have 3. And what we can keep noticing, by the way, is that basically what happens is they shift, right? Because what's happening is it shifts in from the middle. What do I mean by that? I mean, right now there's 0 in the correct orientation. This one switches to the correct orientation. This one is not in the correct orientation. Now 2 become in the correct orientation, and this that was here goes right here. Right? And this that was here goes right here. And this one shifts to the correct orientation. See what I mean? So once again now, this will shift right here, and this will go to the correct orientation. Now we have 2 and 3 because the same thing happened here. And so basically, if it doesn't shift, if it doesn't shift, then it goes to correct orientation, and then finally we have 7. So we can notice some of these patterns, and as we learn more about the problem, basically what will eventually be noticed is, here's the problem, okay? Let's say I have a right. I have this right. Following a right, what's the long substring of lefts? There's this really long substring of lefts. Now what's going to happen to this substring, right? The right, okay, because it's facing, the first one is now going to turn. So we're going to have now this way, which is going to be like this. And then, right, you know what I mean? Are you following that step, Graham?
Yes, I understand that.
So this has just moved over one. And now the same thing is going to happen. So this one is going to switch, and now we're going to have this all the way. And now it's going to do this. And so on and on. And basically, it's going to take one for all of these substrings. So what do you notice then? You notice that this, essentially, that the substrings are really important, because if I can find this longest substring of L's, then it doesn't matter what else is going on in the of things of this form. It doesn't matter what else is going on in the list, because those don't count as extra steps. As in, if this substring takes the most steps, then these substrings won't matter, right? Like these will actually have the same thing to do, because these ones will also go and turn this way. And then will become, again, like this, right? You know what I'm saying? And then like this. But these don't matter, because these will be happening concurrently as these ones, right? And these ones take longer. So in each step, I'll just get one of these done at the same time, then 2, right? Then 3. But then there's going to be 4, 5, 6 here, and these will already be done and in the correct orientation. But what I'm trying to say here is, we notice, basically, and I guess I'm kind of giving you the answer, but that's okay, that if I can find, it's still hard to actually compute, to write the program for it, so you can do that if you want to. But that's the idea, is if I can figure out that, hey, I don't actually need to simulate the whole thing. All I need to do is figure out, basically, how long the longest substring will take, which is this one right here, then you're done.
Right.
Because all you need to figure out is how long will it take for those to get to the end. Say, kind of similar deal here, right? If I have a string like this, I know that this will have to go here, and then I can figure out what's going to happen on this end. And so basically what you do is you do enough of these that you determine this general pattern that lets you basically solve it for the whole thing.
Right.
Cool, eh?
Yeah. That's what I was thinking. Like when I first saw the question, I thought that there was some sort of like pattern or like exponential number that you would multiply it by or something like that to just get the final number of steps instead of trying to fully run through the entire thing. But I just never like went down that path because I thought it would take too long or it might not yield anything.
Yeah. You were on the right track in that sense. Were you the one who posted the Piazza question about like 1.9 whatever?
No, that was not me. No.
Okay, well, there was someone on Piazza who posted and basically asked if they were on the right track, because they found that basically, I think they took like the length of the string or the length of a certain substring and multiplied it by 1.9 something, but they found that that was close but always slightly inaccurate. And they found that as the string length got longer, it tended to be that number would not be 1.9, and would be closer and closer and closer to 2. And that is an interesting way. And I told him that they're actually, and I know, I mean, I don't actually know what the solution is, but I believe there is a solution based on that, which basically uses that as a basis and then make some corrections afterwards. So if you find the ideal number, you can make some corrections afterwards based on, you can basically, because right, like to determine the length, you don't need to loop through the string. And even if you did, it would be very fast, right? So what you could do, you could determine the length, and then you could, and when I say length, I mean the length of the string. Do the 1.9 thing, and then you could loop through once. And if you're looking for certain flags which will increase the value slightly, right? Like you notice that it was always slightly too low, that will increase the value slightly. And I don't know based on the 1.9 thing what those flags are, but I'm sure that there is a consistent method. Like there's a there is a method to this madness. Then you could do it the same way, right? You could multiply by 1.9 and then just loop through and add when necessary.
Okay. Yeah. Okay.
Like honestly, it's probably something simple. Like it's probably you just add the number of these in the string or something like that, and it will work.
Okay. Okay.
I don't know that. I don't know. I'm just guessing here, but
Right.
but that's. I mean, that's how I solved the problem. I mean, when I came up with it, right? Like,
Okay. Maybe I'll have to give it a try after I finish my assignments.
yeah, definitely do it after assignments. But if you're curious and like, feel free to. I mean, I quite like this problem, and I'm happy to help if you want to figure it out. So just like, if you have questions or whatever, you can just send me an email, and well, if you have Discord, you can message me on Discord for stuff like that too. Especially because this is like totally not formal, and I would be more than happy to help you however you want.
Okay, cool. Thank you.
No problem.
All right.
All right. Thanks for coming, and thanks for all your questions. I'm both of you. I appreciate it, and it was great to answer questions and help. If you have more questions, Anna, feel free.
Thank you. Just one question. It's the final exam, right? What is the level of difficulty? Do you think like you'll have questions like the one that you just shared, like the bonus question?
No. So no. The short answer is we're not expecting knowledge of anything like the bonus in this course, and the truth is that is a hard problem to solve. Like, it even took me some time. That's why I didn't intend it as a bonus. I wrote the question 5. You will definitely see stuff like that on the exam, as you can see, by the way, from like the from the solution I just showed you. The base question 5 is not that difficult. It's kind of like it seems difficult, and the difficulty is coming up with the solution on your own. You will have stuff like that. We're going to expect you to be able to figure out stuff on your own, that's for sure. But we're not going to be expecting anything like that. Like, you will not need pen and paper for the final exam like you did with or you would have with this bonus. I would say, in terms of difficulty, it's probably not that much harder than the midterm. There are different concepts, like we're going to be doing like files and errors and classes and stuff. So it's probably slightly more difficult in terms of the conceptual stuff, but it's just that it's including more content. It's not a particularly more challenging application of the content.
Okay. Well, thank you for answering that.
Yeah. I mean, we haven't, like, truthfully, we haven't written the exam. I mean, we usually write them a week or two beforehand, but I'm, from my experience and from what we're planning on, I can just answer that.
Awesome. Thank you so much for your assistance.
No problem. Thanks for coming, guys. Unless there's anything else, I will wrap up here.
No, I don't have anything else. Thank you.
Okay.
Thank
Have a
you.
good evening.
Bye.
Bye, Sarth.